Hello, everybody. My name is Henry Ferris, and I'm here to do the demo for the third project for networking for multiplayer games, that being Fruit Ninjas. Um, I'll try to keep my code discussion relatively concise. I don't want to spend too much time on redundant content, especially considering what is being reused from the past two projects. One big thing I did want to talk about first is our architecture split, especially regarding authority. Um, of course, there are many architectures for authority. You could put it client side, you could put it server side, and there are some kind of non-binary options in the middle there. The approach I chose to go with, and I believe a lot of my peers probably chose to go with as well, um, is fully server authoritative. It's relatively simple, and as long as the bandwidth can support it and gameplay remains smooth, then it's a pretty robust and simple solution. One function which allows me to show that off is handle data here. Um, Here where this is after we've taken it in, following kind of the same architecture you saw in the last project, and we handle all of our parsing and processing server side before it's sent back out, so that we don't need to worry about peer-to-peer connections and any of the sort of desyncing or mismatching or additional overhead that can cause. Pardon me. Um, we can also look at functions like here, handle network, um, or see 110, or handle data as we mentioned previously. This ties into our kind of general message standards where we're accepting either accept or data events coming in from the network sentry. Again, tying into that kind of pre-established architecture from prior projects. Um, Moving into actual player creation, how the players themselves are handled. I will drop down to 150. Sorry, I'm looking over at my notes here. Um, so on connect, the server creates a sword and a points object associated with each player's connected socket. And then IDs are created deterministically so that clients can create or update their objects by ID very consistently. Moving into some of our kind of larger, like multiplayer handling logic, we can look down towards like 239. So I decided to go with a readying system. Shortly after getting my kind of initial multiplayer stuff working, um, I realized that I was just running the timer on server time, and that really wasn't viable. Of course, there are a bunch of solutions here. You can do lobbies, you can have just a delay until the actual game starts. But I decided to do a ready system. Um, so we wait for a message until every connected player has pressed R to ready up before the game actually starts. Uh, Nothing too crazy there. I'm sure you guys have seen it before. But yeah, I felt it was a really good solution. Worked out pretty neatly. Oh, another piece of validation here is actually validating that there are at least two players, as we were given the explicit requirements of 2 to 5 players and not 1 to 5 players. Um, let's see here. Oh, so our actual kind of communications and synchronization and loop. Uh, so we can actually see that starting down here around 275, syncing swords, syncing points, syncing new fruits. It's worth mentioning. I know we discussed this a pretty good amount in class. Most people should know this, but you only actually need to update when there's a new fruit. You don't need to constantly repeat fruit values, so just send over that vector with the fruit starting position and where it's going. And that's all the syncing you need for fruits. Um, Moving into some of the details of pre-gaming messaging, we already went over the requirement for 2 players and readying up. Let's see here. Well, that's about most of it. So I'll get us right into the actual game. Uh, no, we don't want EX server. So I built not that one either. So I built build. So we got to launch the server client. It's built all the way into release. So all of the important stuff is passed into the actual release folder. Same way I handled it on the last assignment, just a little bit more stuff to actually move and copy over on build. So this is our server, headless, just a terminal sitting there. And then we can go over to our client in the exact same way. So I'm going to open actually 6 examples of this. So that's 2, 3, 4, 5, 6. I'm just going to tidy these up really quick. While I'm doing that, I can kind of discuss. So I do rather have multi-network stuff set up. I just don't have access to my desktop right now. I did start pre-filling. See, that's 5. I think I missed one here. That's 2. I'm sorry. It's probably skipped for 10 seconds. Oh my goodness. Seriously, there we are. Okay, we have all of them. So the reason I'm pulling out 6 here is I do want to show how we actually decline after hitting a maximum supported amount. So we're going to connect on just 2 for now. So that is default port. Now you can hear some of that audio coming through. We're going to connect on a second one, and look, we have both of them moving. So now we're pressing R for ready, but it wants all of them. This person needs to ready up too, but we're going to connect people first. So with this window, that's 5. I'm maxing it out. So if I connect this one, it'll gracefully decline and just send them back to their starting screen. So now I can go through and ready everybody up. Pressing R in all the windows. So now we've started. Gets rid of that content window. I can slice stuff in various windows. Be a little overstimulating. I've seen this all before. Let me see if I can get a kudos. So that's coming. I'm going to pause the recording for. To save more time there. But runs out. Of course, in that case, that happens to be player 3. It says up here, game over, and it closes gracefully, just like the initial version. That's about all I got for the demo. Thank you.